All right, seniors, I'm just going to do a couple of your homework problems, go through a little bit of how to rationalize the numerator for a limit problem, and then I'll look at one that involves some trig, and then we'll do one using the squeeze theorem as well. So here's three problems. These are odd problems, so the solutions are in your book. But one of the things we do when we encounter this kind of problem, you've got the limit as x approaches 0 of the square root of x plus 5 minus the square root of 5 over x. Now if we simply put in a 0 here, you'll see that the denominator of the fraction here, that's a big fat arrow, let's make it a little smaller, is going to become 0, and that's going to leave us with a 0 in the denominator of the fraction. That's going to give us an indeterminate form. And so what we're going to do, erase some of this here, erase that. All right. What we're going to do is we're going to do a technique called rationalizing the numerator. And it's a lot like multiplying by the conjugate. It really is multiplying by the conjugate. When we did complex numbers in Algebra 2 and a little bit in pre-calc, we rationalized the denominator or rationalized the numerator of a fraction. And so we're going to multiply by x plus 5, square root of x plus 5. Instead of having minus 5 over here, we're going to go plus 5. Now if I just did that by itself, that would change the problem. So I'm really multiplying by something that equals 1, so it doesn't have any effect on the problem. Square root of x plus 5 plus, oh, this should be square root of 5, square root of 5. Alright, so I have the same thing in the numerator and the denominator of this fraction. So I'm not changing the problem. And we can use this as a trick. And what we're really trying to do is rationalize this numerator of this problem so that we don't end up getting a 0 on the bottom. So if we FOIL this, or if we multiply this out, you're going to have the square root of x plus 5 times the square root of x plus 5, your first terms, and that's going to equal just what's underneath the radical sign, x plus 5. Okay, and then if I multiply my inner terms, I've got negative square root of 5 times this, and plus square root of 5 times this. So those will cancel each other out, and I actually get 0 for this times this, and my outer times my other outer term. So then I simply have to go to the end and do negative square root of 5 times positive square root of 5 gives me minus 5. So as you can see, the top part, I'm not going to worry about the bottom part quite yet. The top part simplifies to x plus 5 minus 5, which just gives me an x in the numerator. All right, I'm going to click to the next slide here. It's going to change the problem a little bit. All right, so here's a little more neat technique, but when you do that, when you rationalize that numerator, we ended up with x on the top. All right, so if we look at the denominator now, I have an x times this whole denominator here. So parentheses, square root x plus 5 plus square root of 5. Close parentheses. Now if you see here, we've got an x in the numerator and the denominator. Those cancel, leaving me with just a 1 in the numerator. So what we're hoping now is that when I input this 0 in for x, so I'm going to make this a 0, I can now solve this problem by direct substitution. And if you look at that, what I've got here is 0 plus 5 and under the square root sign, so I end up with in the denominator. Go to the next slide here. I'm going to end up with a 0 here. 0 plus 5, I get square root of 5 plus square root of 5. That gives me 2 square roots of 5. And again, they don't like to leave, we don't leave radicals in the denominator, so they're going to multiply both top and bottom by square root of 5. Square root of 5 over square root of 5. That does not look at all like a 5. Square root of 5 over square root of 5. And that's going to end up giving us square root of 5 over 10 for our final solution. So that technique is called rationalizing the numerator. Rationalizing technique. Here's a second problem. This problem involves some trigonometry. If you remember, we had two identities. One of them was that if I have the limit as x approaches 0 of sine of x over x, the limit as x went to 0 of this trig function is equal to 1. All right? And we looked at that and showed that in class the other day. If you look, this problem very much fits this form. The only thing that's different is this 5 down here. Otherwise, if I break that apart, it's going to look like this, sine of x over x. So that's what I'm going to do. I'm going to try to I'm going to factor out a 1/5. So that 5 in the denominator, I'm going to factor that out. And then I have sine of x over x, which I know this whole part equals 1. Okay? So let's look at how that one ends up. So they separated the 5 by making it 1/5, and the limit of 1/5 is 1/5, right? Because that's a constant number. This limit is going to approach 1, and so as you'll see on the next slide here, we get 1/5, 1 times 1/5, and the limit becomes 1/5. So again, looking for some of these identities. This one you just kind of have to memorize because it's a trig identity. But again, it looks like as x approaches 0, this should be undefined, but we define this specific limit in class, so you can use that to find other limits then. All right, the third one here, we're going to use the squeeze theorem. And in this problem, this is problem 89 from your textbook, it said define the limit as x approaches 0 of f of x, if f of x is between this function here, 4 minus x squared, and 4 plus x squared. So f of x was in between here. So all they did in this first step in your solutions is add limit notation to the problem. So if the function f of x is between 4 minus x squared and 4 plus x squared, it makes sense to think that the limit as x approaches 0 is going to be between all these as well. So this is using the technique called the squeeze theorem. All right, and so the limit as x approaches 0, this is a problem we can solve by direct substitution. I put a 0 in for both of those. 4 minus 0 is 4. 4 plus 0 is also 4. So the limit of f of x has to be between 4 and 4, or equal to 4. The only number between there is 4. And so the limit of f of x as x approaches 0 is also equal to 4. So hopefully that helps you out a little bit as you're trying some of these problems from section 1.3.